Let's talk about 1.2 day 1. So the first question asks, why are domains different for different functions? Well, the domain is all possible inputs, and some inputs are simply not possible for some functions. Specifically, we worry about where you divide by 0 and if you ever take the square root of a negative. So that means if we have this function right here and you ask me to find the domain, again, every time I write stuff over 0 and square root of a negative. In this case, there are no fractions, so I don't have to worry about this. And there are no square roots, so I don't have to worry about this. So the domain turns out to be all reals. For number 9, if this is our function, again, every time when you ask me domain, I'm going to write down stuff over 0 and square root of negative. And since there is a radical, I know that this is going to be my domain restriction, my problem. So I take the radicand, the thing under the radical, and I set it greater than or equal to 0 because that's what I want. And when I solve, I get that x is less than or equal to 3. So what does that mean? That means I can draw my picture and you're allowed to either be 3 or be less than it. And when we look at interval notation, that means you can go all the way up to 3 and go down as far as you want. Right, so that's 9. 17, so if this is my function x minus 3 over x squared plus 9x minus 22, then if you ask me to find the domain, I'm always going to write stuff over 0 or square root of a negative for every problem, because by the time I get to the exam, I will know what to do. So it looks like this is going to be a problem here because I do have a division symbol. So in that case, I set the denominator equal to 0, because that's the only way I can have stuff divided by 0. So I show the denominator equal to 0, and I know that this is now, I love this because this is set equal to 0, and I can factor. So I love it when stuff is set equal to 0 because that means I can factor. And on the left-hand side, I know the first two have to multiply together to get the first, and the last two have to multiply together to get the last. So it factors like so. But if those two things multiply together to get 0, either that 0 or that 0, and so I have my two values. But notice, those are the two places that you are not allowed to be. So on my number line, I would put holes there at -11 and at 2, and you're allowed to be anything else except those two values. Well, that would just mean that this interval is written like this interval is written like this, and the last interval is written like this. Notice they're all open because we do not include any points. All right, now for 2x plus 1 over the square root of 5 minus x. Again, if you ask me for the domain, every time I'm going to write stuff over 0 and square root of a negative. In this case, stuff over 0 is a problem because I do have a fraction. So I'm going to deal with that first. Since I have a fraction, I'm going to set the denominator equal to 0. So I take the whole denominator and set it equal to 0. The only way the square root can be 0, if I square both sides, is that 5 minus x is 0. So again, all I did here was square both sides to get this, and now you add x to get this. So this is the only place where the denominator is 0. So that means that we don't want that to be 0. And so you can be any of these values except that. And so we also have to worry about this. See you, have a good one. And that is because we have a square root, so we have to worry about square root of negative. So we're going to take that radicand and put it greater than or equal to 0. That means that this must be greater than or equal to 0. So 5 is greater than or equal to x in this case. And so when I draw that on my number line, it's going to look like this. But what we really do is we put those two number lines together so that we can find out where we can satisfy both conditions. As we walk from left to right, all these points seem to satisfy both, so they are all in our domain of the whole function. But 5 is not satisfied by both, neither is any other point, so that is our whole domain. 23. again, anytime we're working with domain on these easy functions, we worry about stuff over 0, square root of a negative, or an even root. So in this case, do we worry about stuff over 0? Well, yes, because we do have a fraction. And so that means stuff over 0, I'm going to set my denominator equal to 0. So I set the whole bottom equal to 0. And then I guess I square both sides, and I get x is equal to 4 as a bad place. What does that mean? Give me just 1 second. What that is trying to tell you is that you can be anything except 4. Then, square root of a negative, is that a problem? Well, yes, because I have a square root on the top. So that means I take its radicand, the thing under the radical, make it greater than or equal to 0, and in that case, I find out that x must be greater than 6, or equal to 6. And lastly, if I put the other radicand, it's in the bottom because it's got a square root, this stuff must also be greater than or equal to 0, but that would require that x is greater than or equal to 4. So then if I put all 3 of those on top of each other, very thoughtfully, I can see that now as I walk from left to right, I'm trying to find out what values satisfy each. Well, nothing is satisfied until I get to 6 for this one, but 6 works for everybody, and so does every point after it. So it turns out that our domain is from 6 to infinity, including 6. 24, in this case, if you ask me to find the domain, I have division, so I set the denominator equal to 0. So this is telling me x can't be 0, but it looks like we can be anything else. So the domain is this. Why does that make sense? When these cancel out, I get 1 only if x is not 0, so our graph is just the constant function 1 with a hole at 0. 25, you ask me to find the domain, and I say stuff over 0 or square root of negative. In this case, because I have a fraction, it's going to be stuff over 0. So I'm going to end up setting my denominator equal to 0. Well, what I'm going to do actually is I'm going to factor the entire top and bottom just to kind of see what's going on. And that tells me when these cancel out, I actually have a hole at x equals 9. We'll talk more about rational functions like this in an upcoming section. But for now, just know I have this function as long as x is not equal to 9. Or in other words, if I set the denominator equal to 0, I find out these are my 2 bad points. And so I can be anything except those values. That means my denominator tells me that my domain is this. 29, when we look on the graph, the domain are just the x values. So it would be 2 to 6, including both. And the range are just the y values. So it's -2 to +6. So we want to write that correctly. I think I wrote that backwards. So that would be -6 up to -2, including, right? And then it looks like the last problem, when we're thinking about domain for this thing, it looks like we just go from -4 out to infinity. So it goes this way when we're thinking about domain. And then range, it seems like we get all the way down from -2 to infinity. Great work. See you next time.